So this is probably going to be the hardest question that we've done so far. We've got two graphs that are given to us, and the red graph is the original graph and the blue graph is the image. And they tell us that there's been vertical and horizontal stretches and compressions that have happened. And we need to write an equation for that blue graph in terms of the red graph. So it's our job to try to figure out what kind of stretches have happened. What has happened to horizontally, what has happened vertically. So like I said, we're going to do two methods. So I'm sort of going to draw a line here. We're going to figure out something that's happened with the horizontal, with your x values, or your horizontal distances, and something that's happened with your vertical distances. And in the first method that I'm going to show you, you will need 2 points on your original graph and 2 points on your corresponding graph. And you can see from the graph here, they've got one set of points on each labeled and another couple points that actually have points on there. So I'm going to call this point down here A, and it's at 2, -8. I'm going to call this point up here B. It's at 3, 9. Now, when we write corresponding points on an image graph, since this point at 1, -4 corresponds to this point at 2, -8, a notation that we often use is A with a little dash above it, or A prime. And that's just to help us realize, oh, that's where that point went. And similarly, this one right here we'll call B prime, because it's related to B. So method one, if we're trying to figure out what kind of stretches and compressions are made both horizontally and vertically, we're going to look at, well, what is the original horizontal distance between A to B? If you went from A to B and you were just thinking about the x values, can you see that you've gone 1 to the right? That's just your x values. You're going from 2 to 3. So the horizontal distance between A and B is 1. The horizontal distance from A prime to B prime, now we're going from 1 to 1.5, is 0.5. So now we're going to look at that and say, if I went from 1 to 0.5, what would I have had to have multiplied my x values by? To do that, I'd had to multiply my x values by 1/2 to go from 1 to 0.5. Similarly with the vertical distances, when we go from A to B, we go from -8 up to 9. We're going up 17. And it's important to not just count the distance as 17. In this case, A to B is going up, so that's positive. Sometimes you're going to go from A to B and it's going to be down. That needs to be negative, because sometimes you'll have a reflection built into these as well. So the order does matter. And going from A to B is going up 17. Now going from A prime to B prime, again, now we're looking at the y values because we're looking for vertical distances. We go from -4 up to 4.5. So we're going up 8.5. Is there a way to multiply 17 to get 8.5? Wow, do you ever have issues with squiggle brackets? I don't know, like that one just, okay, well, done. Okay, let's try that. There we go. Oh, wow. I might have to take a picture of that one. That one's one of the nicest ones. Okay, so what's happening to y? Y is getting multiplied by 1/2. Now that is the harder way, because you need two sets of points on each. You have to look at the original horizontal distance and the new horizontal distance to figure it out. When there is just a vertical and horizontal compression and not any translations happening, if we just think about the points that were labeled, if you went from 3,9 on your original one and you changed, oops, to 1.5, 4.5. For your horizontal distance, that would be looking at your x's. What do you have to multiply x by to get from 3 to 1.5? A half. And if we do that same point for vertical, and you look at the y, what would you have written y had to be multiplied by? A half. So you can see that that's a lot easier, right? You just have to look at the point and figure it out. But I'm telling you that that only works when there's just horizontal and vertical stretches, compressions. If we add a translation to that, you would have to use technique number 1. So that's why I showed it to you first, because sometimes people are like, I just want to do one technique that I know is going to work in the different situations. Perfect. If you like to know more than one technique and you like, in this situation, I like the shortcut. Perfect. You can use that as well. So now that we know what has to happen, we can write the equation in terms of f. So the equation for the blue graph is going to be y equals anything that happens to y is exactly as you think it should. So that half multiplying y by half will be outside the function and a half in front. And anything that happens inside the function for a horizontal stretch or compression, if you're multiplying x by 2, that's going to show up as the reciprocal inside. Okay, questions for practice. 5, 12, 13, and 14. I'll give you about 5 minutes just to try those for a bit.